Problems 16, 17, 18, and 19. We are looking for the horizontal asymptote, if there is one. Really, horizontal asymptote is just saying what's the limit as x approaches either negative infinity or positive infinity of the function. So what's going on when x gets really large or when x gets super negative? In number 16, if we were to plug in like 10 bazillion for x, we would get pretty much infinity over pretty much infinity. However, if you look for where the greatest power of x is, it lies in the denominator, which means it's going to kind of model this sort of function. This is the simplest function where the greatest power of x is in the denominator. And if you know anything about what the graph of this looks like, as x gets really large, you're going to be taking 1 divided by a billion, 1 divided by a trillion. You're basically getting 0. Oops, I needed it to be an equation. So as x gets very large, the function here is approaching 0. For number 17, if you let theta, in this case, get really large, you're getting infinity plus, well, sine of infinity doesn't vary very much. No matter what you plug in for theta here, you're going to get something between -1 and 1. So even at its greatest value, the result's still going to be 1. No matter how big theta is, sine of it will never top 1. And the bottom is infinity as well. Essentially what happens then is that this term is irrelevant. You really have some number divided by itself, which is going to give you 1. Another way of looking at it, the greatest power of theta is a tie. It's in both the numerator and the denominator. Then you can just make a ratio out of their coefficients. And since both coefficients are 1, your ratio will be 1 over 1, which is 1. All right, number 18. Once again, we want to probably look, it's a rational function. You've got a polynomial on top and a polynomial on bottom. There's no mystery powers of x here. They're all integer or whole number values of x for the powers. So if you let x get really large, you're going to get kind of like infinity over infinity, which is indeterminate. So what you do is you look for where the greatest power of x is. And in this case, it's in the top. So just like if you had a simple function like x over 1, this also has the greatest power of x in the top. And if x got really, really, really large, the values for y would just keep getting larger and larger and larger as well. So the graph, I don't know exactly what it looks like, but it's taken off. It's going way up through the clouds as x gets large, which means there just is not a horizontal asymptote for this function. And then that takes us to 19. For 19, if you let x get large, if you let x approach infinity, you're essentially getting 1 over infinity for the top power and e to the 1 over infinity for the bottom power. Well, 1 divided by infinity is basically 0. It is 0. So we really have e to the 0 minus 4 on top and e to the 0 plus 4 on bottom. Anything to the 0 power except 0. But e to the 0 is certainly 1, and e to the 0 down here is certainly 1. If you simplify this, you get -3 over 5. I do need to make that an equation. So the equation for the horizontal asymptote is y equals -3/5.